This is Pre-Calculus section 2.8 part 2 notes. We have one last example to finish up in section 2.8. It says to graph the function f of x equals the square root of x minus 1 and its inverse on the same grid. So we're going to start by graphing the function f of x. And since I have a square root over x minus 1, obviously I only want to choose x values that are going to be in my domain. I can't let what's under my square root become anything that's smaller than 0. So if I were to plug in 1 for my x value, 1 minus 1 is going to give me 0, and the square root of 0 is 0. If I were to plug in x equals 2, 2 minus 1 would give me a 1, and the square root of 1 is 1. And then if I want to keep things to nice perfect ordered pairs and I want to keep a perfect square under there, the next perfect square would be 4. So I'm going to plug in 5 for x because 5 minus 1 under the radical makes 4 and the square root of 4 is 2. Okay, now notice that there is not a plus or minus in front of this radical, so that means that I am only graphing the positive square root of x minus 1. So I go ahead and I plot these points. When x is 1, y is 0. When x is 2, y is 1. And when x is 5, y is 2. So that gives me this function right here. Basically, our function f of x is like a half of a parabola laying on its side, a square root function. That's what they look like. Okay, now we're going to graph f inverse. And f inverse, in order to graph that, all we're going to do is we're going to just switch our x and our y values in the table. It's as easy as that because an inverse of a function, we're just switching x and y. So I'm going to rewrite my table, but I'm going to put my y values in the x spot, and I'm going to put my x values in the y spot. And now I'm going to go ahead and plot these points. When x is 0, y is 1. When x is 1, y is 2. And when x is 2, y is 5. So this is f inverse of x. And the question that is being asked is, what relationship exists between the graph of a function and the graph of its inverse? Well, if you look at this graph and you sort of tilt it a little bit diagonally, perhaps you would notice that these two graphs are kind of mirror images of each other over an invisible diagonal line. So if I were to go ahead and I were to draw in that invisible diagonal line, that's this line right here. That's the mirror between my two functions. Okay, so the answer to this question is that they are reflections of each other. And that line that I just sketched in, that dotted mirror line, that's the line y equals x. And that relationship always exists between the graph of a function and the graph of its inverse. So if you are ever given a graph of a function and asked to graph its inverse and you don't know the equation but you have a graph, just sketch in your y equals x line, identify some key points on your graph, flip-flop your x and your y values and plot the points on your inverse function and connect your points. And it's as easy as that.